Welcome back to my channel. Today's LeetCode DCC question is find bottom left tree value. So the problem statement given is given the root of a binary tree, we have to return the leftmost value in the last row of the tree. So in the given example 1, we can see this is row 0, this is row 1, and the last row of this tree is row 1, and the leftmost value of the row 1 is 1. So we have to return this value. So let's see how we can approach this question with another example. If we take example 2, so this is row 0, this is row 1, this is row 2, and this is row 3. So let's mark this is row 0, row 1, row 2, row 3. And we will keep two variable last row seen. So initially we haven't seen any of the row of a tree. So we will mark it as -1. And also we will update keep the leftmost value, and initially we will keep it -1. So now we will traverse the tree. So starting from the root node, so this node belongs to row number 0. So we will check whether we have seen row 0 or not. So the last row seen is -1. That means we haven't seen row 0. So we will update the last row seen with 0 and the value with 1. Now we will call the left children of this node. So left children of this node belongs to row 1. So we can see the last row seen is smaller than the current row. So we will update this with 1 and we will update the value with 2. Again, we will call the left children of this node. We can see the left children of this node belongs to row 2 and the last row seen is smaller than row 2. So we will update that with 2 and we will update the value as well and we will update it with 4. So we can see there is no left children and no right children. So we'll go back to its parent. And again, we can see there is no right children. We will again go back to its parent. Here we can see we have a right children. So we'll call the right children. So right children belongs to row 1. And the last row seen value is 2. That means row 1 is smaller than the last row we have seen. So we will not do anything. And we will call the left children of this node. Left node of children of this node is belongs to row 2 and the last row seen is row 2. So in this case, do we need to update the value or not? So if we see the traversal we have followed is root, left and right. That is pre-order traversal. That is root, left and then right. So in this we can see we are always visiting the left node, leftmost value first, and then we are visiting the rightmost value. That means if we have already seen last row number 2 and we have a value, that means this is the leftmost value of this row, so we will not do anything. So instead of pre-order traversal, if we follow post-order traversal also, in this we can see the traversal is like left, right and then root, or in order traversal also it is like left, root and then right. So in order traversal we can see we are always visiting the leftmost children and then we are visiting the right. So it doesn't matter which traversal we are following. Once we have seen that row, that means we have the leftmost value and we will not update if we come to that row again. So now we will call the left children again. So the left children belongs to row 3. Now we can see the last row seen was 2. And now we are at row 3. That means this was not the last row. So we will update this row value with 3 and the value of the leftmost value with 7. So since there is no children, we will go back to its parent. And since we don't have any right children for this node, we will again go back to its parent. And here we have the right children. So we will come to its right children and we can see this node belongs to row 2 and last row seen is 3. That means we have already seen row 2 and that is not the last row. So we will not do anything. Now since there is no right children or left children of this node, so we will not do anything. And since we have already visited all the nodes, so at the end we can see the last row of this tree is 3 and the leftmost value of this tree is of this tree and the last row belongs to 3. The value will be 7. So we have to return this value. Now, in order to keep track of the row number for every node, so what we will do, so when we will call the root node of a root node, so we'll pass the value 0. And when we will call the left children or right children of this node, we will just increment the row value with 1 and we will call this children node. So the root node has the row value 0. So we will increment by 1. Then the children will receive value 1. Now both the children will receive the row number as 1. Now if children node is calling its own children, then we will again increment the value by 1. So it will receive the row number as 2. So in this way, we can keep track of the row number as well for every node. So I hope the problem statement as well as the solution is clear. Let's try to code. So initially, we have said like we will keep a variable last row seen. And initially, we haven't seen any row. We will keep it as -1 and leftmost value also. And initially, we will keep it as -1. Now we will traverse the tree. So we will accept two parameters, the current node and the row number. If the address of the node is null, we will simply return. Else, we will check whether this row number is greater than the last row seen or not. If it is greater than last row seen, that means we got a new row which is greater than the last row seen. So we will update last row seen with the row number and also we will update the leftmost value with the current value. Now we will call the left child of the node and we will increment the row number by 1. Similarly, we will call the right children and we will update the increment the row number and we will call it. So in this, at first we will pass the root node address and the row number will be 0. So after traversing, after this function is completed, function call is completed, we will simply return the leftmost value. So let's try to run this test cases. It's left and it's right. So we can see the test case has been accepted. Let's try to submit. So the solution has been accepted. So time complexity of this solution will be, since we are traversing every node twice, so time complexity of this node will be 2 of number of nodes, that is big O of n. I hope the solution is clear. See you in the next video.